Hi, welcome to Business Analytics course. This is Dr. Aruna, Associate Professor from MLR Institute of Technology. In today's session, we are going to discuss about measures of dispersion. Measures of dispersion. The overall, in today's session, we are going to discuss about the measures of dispersion, where we are going to explore what is the definition of dispersion, what is range, what is quartile deviation, what is mean deviation, what is variance, and what is standard deviation. Apart from this all comes under absolute measures. So under measures of dispersion, we are also having relative measures where we are going to focus on coefficients of these absolute measures, that is quotient of range, quotient of variance, quotient of mean deviation, and quotient of quartile deviation. Now, let us see the definition of dispersion. Dispersion is the extent to which the data values are spread out or scattered around the central value. In simple, we call it as the central value is nothing but the mean or the average. So, the extent to which the data values are scattered around the mean value is nothing but dispersion. Statistical dispersion means the extent to which the numerical data is likely to vary about the average value. As in the previous sentence we are seeing, it is likely the mean. So, it is nothing but the average value. It helps us to understand the distribution of the data. So, in this measures of dispersion, we are having the first one as range, second one is mean deviation, third one is variance, fourth one is standard deviation, and also we have quartile deviation. The fifth one is quartile deviation, which we are missing here in the picture, quartile deviation. So, these are the 5 things which we are going to discuss in this present session. Now, the first of all is the range. Range is the simplest measure when it comes to measures of dispersion, and it is the difference between highest observation and the lowest observation. Or in simple words, we can say range is the difference between the maximum value or the minimum value, or it is the difference between the maximum observation and the minimum observation in the data set. Now, one more point to note here is, it is very easy to calculate, but it is affected by extreme values. So, what is this extreme values? So, the lowest value, highest value. So, if any changes are there in the highest and the lowest value, automatically it is going to have an impact on the range. So, it is clearly affected by the extreme values. Now, for every measures of dispersion, we are going to have the default function in Excel, but for some kinds of measures or some measures, we may not be having directly the default functions in Excel, but we can create, or we can form a kind of function where we can get the value for that. Now, when it comes to range, range is nothing but the maximum value minus minimum value, as we have told in this simple formula. So, the Excel function is the maximum of the data range. So, from the data range, we are going to get the maximum value, and we are also going to get the minimum value from the data range, and we are going to see the difference. So, that gives us the value of range in Excel function. So, in the next session, when we are going to explore in Excel, then we are going to see all these things. But as of now, just keep in mind, this Excel function is nothing but maximum of data range minus minimum of data range. The next one is quartile deviation. In short, we call it as QD. And there is another name for it, and that is semi-interquartile range. We call it as semi-IQR. Interquartile range is IQR. So, this is the measure that shows the spread of 50%, middle 50% of the data. So, how we are going to get this? So, this is half of the difference between the third quartile and the first quartile. So, first what we are going to do? We are going to find out the difference between third quartile and first quartile, and to that we are going to half of it. We are going to take half the value of it. So for this also we are going to have Excel function. So that Excel function is quartile.inc data range. Now first we need the third quartile, hence we are using 3 here, minus quartile.inc data range. We are using here 1 because it is a first quartile. Now there is one new word, that is INC here, quartile.inc. In Excel we do have two kinds of functions. One is INC and EXT, that is exclusive, EXC. INC means we are going to include those values also into consideration. But when we are using EXC, we are going to exclude those values into consideration while calculating the quartile deviation. Now, so you may be having a doubt, what is quartile? Quartile means it is nothing but the 25% of the observation. Now, when we talk about the first quartile, it resembles or it represents 25% of the observations. When we call about the third, that is 75% of the observations, we call it as third quartile. Now the difference between these two, that is Q3 minus Q1, is nothing but interquartile range, which we call in short form IQR. And when this IQR is divided by 2, we get the value mean deviation. Moving forward, the third one is mean deviation. Mean deviation, mean also called as average, hence the name. Mean deviation is also called as average deviation. Now, the definition itself gives us the meaning. It is the average of absolute deviations from the mean or median. Say for example, if we consider this particular formula is with respect to mean. So here we are telling it is the average of absolute deviations from the mean. So we are taking x minus mean. So we are taking the deviations. For this, we are summing it up. Summation symbol is there. So we are summing it up and we are finding out the average. So divided by n number of observations. Now for this, the Excel function is, by default, Excel is having a function called as average deviation of data range. In short form, we call it as AVE data range. The next one, variance. So variance is another measure of dispersion where we are going to measure how far each value in the data set is spread out from the mean, means to what extent it is set out from the data mean. Now if we see here, the formula is sigma square is equal to summation x minus x bar whole square divided by n. So here we are finding out what is the spread of data set from the mean. So we are taking out x minus x bar. For this we are taking out the square, and for that we are taking out the mean, we are calculating, dividing it by number of observations. So where x represents the each value, x bar represents the mean, and n represents the number of observations. Now here, for this particular measure, that is variance in Excel, we have got two types of functions. The first one is with respect to population. So with respect to population, we are having one function, default function, and with respect to sample, we are having one kind of function. So here, we need to know what is population and what is sample. So for example, in a class, if there are 60 students, total 60 students, a class can accommodate only 60 students, and for every class there is a possibility of only 60 students. That means if we are considering the entire 60 students, that means we are considering the entire population. So that 60 becomes the population, that is n. Now when we consider the sample means the sample represents the part of the population. Say randomly we are selecting some 15 students or 20 students out of the class. So that becomes the sample. So here, when we talk about the population and sample, here when we are calculating the variance in Excel, in the latest versions, we are having where dot p, where starts for variance, dot p for population, and data range. So whatever the data set we are having, for that if we are to uh, uh, consider that values, that observations, for that what we are doing, if we are assuming it as the entire population, then we are going to use the default function where dot p. Now suppose we are using only the sample data. Say for example, we are using only 15 observations, and that forms the sample. So in that scenario, we are going to use the function where dot s, and we are going to take the data range, means whatever the data set is there, that we are going to take it. And since we are considering it sample, we are supposed to use where dot s. Similar is the case with the next a measure, that is a standard deviation, because standard deviation is nothing but it is the square root of variance. So if we get the value of square variance, simply if we do the square root of it, we are going to get the standard deviation. It simply shows the dispersion in the same units as data. So earlier you have seen variance, that is sigma square is equal to summation x minus x bar whole square by n. Now when we know the variance formula, obviously we can get the standard deviation formula. Standard deviation is equal to square root of variance, so which is equal to sigma. So sigma is equal to square root of summation x minus x bar whole square by n. Like as we have discussed in the previous case, that for variance and for standard deviation, we are having with respect to population and with respect to sample. So here also, like where dot p for population, we are using the default function. Where dot s, we are using it for sample. Here also we are using STDEV, means standard deviation. This is a short form, which is the default function available in Excel. So pretty cool. We are going to use standard deviation, means STDEV dot p for population and STDEV.s for sample. So in this way, we are going to use the functions, default functions for measures of dispersion in Excel. So till now, the range, then quartile deviation, mean deviation, variance, and standard deviation all come under absolute absolute measures. These are the absolute measures in measures of dispersion. So in the previous table, we have seen in the previous slide, under measures of dispersion, we are having absolute measures as well as relative measures. So the absolute measures we have gone through now, all these 5. Now let us have a look at the relative measures. So when it comes to relative measures, we are having 4. The first of its kind is quotient of range. The second one is quotient of variance. The third one is quotient of mean deviation. And the fourth one is quotient of quartile deviation. Now what is this? So range, we know the formula. Range is the highest value minus lowest value. But here when it comes to quotient of a range, we are going to define it as the ratio. The ratio of the difference of highest value to lowest value in the data set to the sum of highest value to lowest value. Now if I take it in the form of a formula, quotient of range, CR, if I can represent, CR is equal to highest value minus lowest value divided by highest value plus lowest value. So this is the formula which we can use it for calculating the quotient of range. Now the second one is quotient of variation. So here we we define it as it is the ratio which gives which brings the relationship between standard deviation and mean. Hence it is defined as it is the ratio of standard deviation to mean of the data set. So when we are talking about when we are taking in the two conditions, like two parameters, not conditions, two parameters like standard deviation and mean of a particular data set, we are going to calculate quotient of variation. Where we are going to use this means, suppose if we are having two different kinds of projects or two different proposals. So we need to find out which one is the better one. Then we can find out making use of the standard deviation and mean. Now simply if you look at the formula, CV, quotient of variation, is equal to standard deviation divided by mean, which is nothing but X bar. Now the third one, quotient of mean deviation. Now whenever we are talking about the quotient, we also see that it is nothing but the ratio. So it is defined as the ratio of mean deviation to the value of the central point. Value of the central point is nothing but the mean. So simply we can write down CMD, quotient of mean deviation, is equal to mean deviation divided by, again, it is nothing but the central point or the value of central point in the data set, which is nothing but the mean. Next, the last one, quotient of quartile deviation. Now this is quartile deviation itself is the meaning Q3 minus Q1. That is the difference of the third quartile and the first quartile. So when it comes to quotient of quartile deviation, here we can write down as quotient of quartile deviation CQD, that is quotient of quartile deviation, is equal to, we are telling quartile deviation is the difference of Q3 minus Q1 divided by, so the difference between the third quartile and the first quartile, to sum of third quartile to first quartile, Q3 by Q1. So if this is not visible, I am writing it here once again. Quotient of quartile deviation is equal to Q3 minus Q1 divided by Q3 plus Q1. This is the formula for quotient of quartile deviation. So we have seen the absolute measures, we have seen the relative measures of dispersion. So mostly for absolute measures, we are going to explore them in the forthcoming session in Excel, how to deal with or how to calculate or how to compute the values like range, how to find out the range, how to find out the mean deviation, how to find out the variance, how to find out the standard deviation by making use of default Excel functions. In today's session, if you look at, we have gone through all the measures of dispersion. Mostly, very importantly, we have seen what is range, we have seen quartile deviation, we have seen mean deviation, we have seen variance, we have also seen standard deviation. And all these 5 are absolute measures. All these 5 are absolute measures. Now, similar to this, we are having the relative measures also, and we have seen 4 different relative measures. That is, one is quotient of range, CR. We have seen quotient of variance, CV. Next, we have also seen quotient of mean deviation, CMD, and also we have seen quartile deviation, CQD. So these are the things which we have seen. If you just go back once, see mean deviation and quartile deviation. So quotient of range, quotient of variation, quotient of mean deviation, and quotient of quartile deviations. So all these 4 are relative measures of dispersion. So in the next session, we are going to see how we are going to compute the absolute measures in Excel by using the default Excel functions. And wherever the default Excel functions are not available, then how we are going to use different formula to get the values. So that we are going to explore in the next session. Until then, stay tuned and thank you.